I'm going to go over a directional derivative, and this one is f of xy is equal to x squared plus 2xy plus 3y squared. We're using a point at 2, 1, and we have a component vector of 1 and 1. Now, I had a couple of students ask this type question and say they're having problems with it, so I thought I'd help them out. Now, of course, you know the way I teach. I don't teach all by the book with the pinky up and all this other stuff, so I'm just going to tell you what you need first. The first thing you need is your unit vector. And in this case, we have our component vector, so we need 1 and 1, so that would be 1 squared plus 1 squared. We have to find our denominator, so that would be 1 over square root of 1 squared plus 1 squared, comma, 1 over 1 squared plus 1 squared, and that's our unit vector, which is equal to 1 over square root of 2 and 1 over square root of 2. Now you're going to need this later in the directional derivative, so just circle that, and let's go ahead and find our partial derivative. Our partial derivative, f sub x, is going to be equal to, and I'm looking at it, that'd be 2x plus 2y plus 0, so that would be 2x plus 2y. And our partial derivative, f sub y, would be 2x plus 3 times 2 is 6y, so that'd be 2x plus 6y. Now you have all your components to find your directional derivative, and I'll try to just leave these over here, right there. Well, I'll put it right up here. Try to put it right, bring this down. There we go. Alright, so our directional derivative, and yes, that's what dd is. You can put d sub u f of x y if you want to, but I don't do that. And we got 2x plus 2y times 1 square root of 2, that's your a, 1 over square root of 2, plus 2x plus 6y times 1 over square root of 2, which is your b. Now this formula is in the book. There's several different variations, the dot product, and then I'll just f of xy, f of x, f sub x, xy times a plus f of y, f sub y, xy times b. That's what I use. And now you just clean that up algebraically, and we get 2x over square root of 2 plus 2y over square root of 2 plus 2x over square root of 2 plus 6y over square root of 2, and then our final outcome is equal to 2x plus 2x is 4x, so that would be 4x over 2, 4x over square root of 2, plus 2y, that would be 8y over square root of 2, and there is your directional derivative. Now of course they give you a point to evaluate at, I think ours was 2, 1, and just plug and chug. 4 times 2 over square root of 2 plus 8 times 1 over square root of 2, and that's going to be equal to 8 square root of 2 plus 8 square root of 2, which is equal to 16 square root of 2, which is equal to, that's going to be equal to, well, that's, you can multiply square root of 2 or 2, 16 be 8 square root of 2. Y'all check my algebra there. I think that should be your answer. Now, we notice that it's a positive slope, and as I showed my students, you have two types of scenarios. Just think of your topography map. Here's your X and Y, your Y and your X, and Z is coming out. So think of this as a hilltop. This is 0 feet, this is 5 feet, this is 10 feet, and this is 15 feet. So here's your hilltop, and water goes downhill. So if you have a point there, you know your water's going downhill, you're going to have what kind of a slope? A negative slope. The other scenario is the other direction. Well, how can you have a reverse hilltop? Well, it's not a reverse hilltop. If you know anything about topography, you know that something like this can either be a hilltop, meaning that the elevation's going up, or your elevation's going down. So this is kind of like a hole. And of course, if I have a point here and I'm trying to go up, that is a positive slope. So in this case, this is a hole. If it was a negative slope, it would be a hilltop. And I hope that helps. 8 square root of 2.